Hey, this is Math 6, Unit 7, Lesson 17 on common multiples. We're going to use multiples to solve various problems. So first of all, we have a notice and wonder activity. It says circle all the multiples of 4 on this list. So we start here and we go 4. We kind of skip counting. 4, 8, 12, 16, 20, and 24 are multiples of 4, right? 4 times 1, 4 times 2, 4 times 3, and so on. Then we want to circle all the multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. So what do you notice and what do you wonder? Maybe you might notice a few things, like with the 4s. There are more multiples here for 4 than there are for 6. You might also notice that there are some that are in common, right? That we have, they both share a 12 as a common multiple, and they both share 24 as a common multiple as well. Okay, interestingly enough, both 12 and 24 are also multiples of what other number? 12. So, interesting that 4 and 6 have common multiples, and their two common multiples are both multiples of 12. So just something interesting there. So things you notice, things that you wonder. Okay. A florist can order roses in bunches of 12 and lilies in bunches of 8. Last month, she ordered the same number of roses and lilies. If she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? Find all the possible combinations. So what we want to think about here is that we're going to be ordering roses in groups of 12 at a time, right? So if we think about our 12s, when we think about our multiples of 12, 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is going to be 36, and we're going to do this all the way till we get up to 100. So times 4 is 48, times 5 is 60, times 6 is 72, times 7 is 84, and then 96. We do the multiples of 8, we're looking at 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. So when I look at this here, these are my multiples of 12 and my multiples of 8. I want to find combinations, that is, I want to find combinations where the numbers are going to be the same. Okay, so I can see 24 and 24 is a common multiple. I can see a 48 and a 48, another common multiple. 60, 52, 84, and then finally I see 96. Oops, I missed one. 72 and 72, and finally 96 and 96. Those are my common multiples for the kind of flowers that could be ordered in groups of 12 and 8 and be the same. So what does this mean? You could order, potentially, now this is where it gets a little complicated, think about it. I'm not ordering 24 flowers, these are bunches, right? This is 12 times 1, 12 times 2, 12 times 3, 4, 5, 6, 7, 8. And down in the 8 section, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many bunches of roses could I order? I could order 2 bunches of roses, and that goes with what? 3 bunches of lilies. Does that make sense? Where it's a total of 24 of each kind. That's where the 24 comes into play there. So I'm getting 2 bunches of roses and 3 bunches of lilies. That's my common number. 24 is the least common multiple, but I want to play with the 2 and the 3. So for the next one, I'm going to get 4 bunches of roses and 6 bunches of lilies, which is going to be a total of 48 of each kind. Then I can get, for 72, another common multiple, that's going to give me 6 bunches of roses and 9 bunches of lilies, which is 72 of each kind. And then finally we have the 96 number, which gives me 8 bunches of roses and 12 bunches of lilies, for 96 of each kind. And that's the idea there, okay? But we have to find our multiples first and then find the common ones out there. All right. Now when it says what is the smallest combination of bunches of roses she could have ordered and the smallest bunches of lilies, we're looking for the least common multiple here, okay? Which we see as the next activity. The smallest number that she could have ordered is going to be right here. That's our smallest number. 2 bunches of roses and 3 bunches of lilies is the smallest bunches she could have ordered, where they end up being the same number, 24. Okay? And we talked about that as being the next activity, the least common multiple. Least common multiple of 6 and 8 is 24. So let's talk about what does that mean, right? When we take a look at 6, 6 is, the multiples of 6 are 6, 12, 18, 24, 30, 36. Multiples of 8 are 8, 16, 24, 32, 40. And we can see that there's a multiple they have in common, which is 24. And we're calling that the least common multiple. So what does that actually mean? What do you think the term least common multiple means? So write down what you think it means. And the idea is that the least common multiple is the smallest multiple that 2 or more numbers share. Okay, so with the 6 and the 8, the smallest number they both shared was a 24. So let's find multiples of 10 and 8 that are less than 100. Okay, and I'll tell you, when I worked on this myself, it's not fun to write out all the way to 100. I wish you could just go to like 50, but we're going on to 100, it's okay. So for multiples of 8, we have 8, we have 16, we have 24, 32, we have 40, we have 48, we have 56, 64, 72, 80, 88, and 96. 10, a little nicer, right? We have 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, what is the common multiples are 40 and 80, and the least common multiple is going to be 40. That is our least common multiple. Sometimes we just abbreviate it like greatest common factor, GCF. We call it the LCM. Okay, let's do the same thing for 7 and 9, which is really fun because those are even smaller numbers. Okay, so 7 and 9, we have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, and 98. For 9, we're looking at 9. We have 18, we have 27, we have 36, we have 45, and we have 54, we have 63, we have 72, we have 81, we have a 90, and we have a 99. Now I'm intentionally writing my numbers a little spaced out so that we can easily see where do I have a match. I have a match right here at 63, and that's it. That is also going to be my least common multiple for those two numbers. So I'm listing out all the multiples of 7, all the multiples of 9 by multiplying it out and then finding which one do they have in common. And that's the whole idea behind what we're doing today. Okay, that's the least common multiple. Okay, a little different than greatest common factor. We're looking for the least common multiple by multiplying them out. Let's take a look at prizes on grand opening day. So Lynn's uncle is opening a bakery. The bakery's grand opening day, he plans to give away prizes to the first 50 customers. Every 5th customer gets a bagel, every 9th customer gets a blueberry muffin, and the 12th customer gets a free slice of carrot cake. Alright, so Diego's waiting in line. He's the 23rd customer. He thinks he should get farther back in line in order to get a prize. Is he right? And if so, how far back should he go to get at least one prize? So to figure this out, we want to think about the line and we want to figure out where the prize is given out. So for the bagel, the bagel is every 5th person. Okay, the blueberry muffin is every 9th person, and then the carrot cake is every 12th person. So you might want to think about what it is that you like too for which place you want to be in line. We're only going up to 50. That's nice, not 100 like the last ones. So person number 5 gets a bagel. 10. We can go 5, 10. Let's do it. Let's spread it out a little bit here so we can make this work. Let's go 5, 10, 15, 20, 25. Oh, too far. I'm going to run out of space. 25, 30, 35, 40, 45, and 50. They all get prizes. The 9s, we have 9, we have 18, 27, 36, and then we have 45, and we're out. For 12, we start here at 12, and 24, 36, and 48. So those are all my prizes, right? Okay, and we can see some that are in common. We can see a 36 they have in common. So person number 36 is getting 2 prizes. Person 45 is getting 2 prizes. And there are the rest of the prizes. Now he's sitting at person number 23. So in terms of like where he's sitting in line, he's number 23. He's located right about here, right? So he's wondering, should he move back in line? I would say that would be a wise idea, because there are a lot more prizes here, right? He could go 1 back and get a carrot cake. He could go 2 back, right? Go back 2 and get himself a bagel. Or he could go back further and go 4 back and get himself a blueberry muffin. So definitely go back further in line. There also seem to be more prizes toward the end, right? Look at the beginning. There's only 1, 2, 3, 4, 5, 6, 7 prizes here. And over here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 prizes on this side of 23. So there's definitely more prizes to go further back in line. All right, Jada is a 36 customer. Wow, way to go, Jada. She's right here at 36. Way to go. Will she get a prize? If so, what will she get? I would say she's going to get a prize. Yes, indeed. What is she going to get? She's going to get the muffin, and she's going to get the carrot cake. She's going to get both. Why is that going to happen? Because 36 is a multiple of 9, and 36 is the multiple of 12. That answers this question. Is it possible for her to get more than 1 prize? Yes, it is. And why? Again, 36 is a multiple of 9, and it's a multiple of 12, which means 2 prizes there. Just like up here, 45 is a multiple of 5, and 45 is a multiple of 9. So the 45th person gets the bagel and the blueberry muffin. What a prize. How many prizes total will Lynn's uncle give away? Well, we had 12 on this side we counted, 7 over here. We would say a total of 19 prizes, right? So you have your bagels, your blueberry muffins, and your carrot cake. Bagels is giving away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. The blueberry muffins is giving away 5, and carrot cake is giving away 4, for a total of, 19 prizes altogether. Let's take a look at our summary real quick. In summary, a multiple of a whole number is a product of that number with another whole number. So a multiple of a whole number is a product of that number with another whole number. So 20 is a multiple of 4 because 20 is 5 times 4 gets you 20. So it's a multiple. We call that a multiple. A common multiple for two whole numbers is a number that is it's multiple for both numbers. So 20 is a multiple of 2 and it's a multiple of 5. So that's in common for both of them. Sometimes we talk about a least common multiple, which is the smallest one they have in common. Okay, so 30 is the least common one for 6 and 10. Are there others they have in common? Yes, but 30 is the smallest. Sometimes the way we do that is we make a list of the multiples, and then we find the smallest multiple they have in common in order to find that least common multiple. Okay, I'm going to pause there, let you work on your homework for a little bit, and then we'll come back together and check it in just a few minutes. All right, here we go, homework time. All right, a little tricky to do this one with the little space that's on here, but it's on one page, so here we go. A green light blinks every 4 seconds, a yellow light blinks every 5 seconds. When will both lights blink at the same time? So you're going to look for a pattern here, right? So here's green, here's yellow. The green one goes every 4 seconds. So it's going to blink at 4, it'll blink at 8, it'll blink at 12, it'll blink at 16, it'll blink at 20, and 24, right? Keeps going. Yellow is going to blink every 5 seconds, so it's going to be blinking at 5, at 10, at 15, at 20, at 25. So when will they blink at the same time? They're definitely blinking at 20 seconds for sure. Will it happen again? Absolutely. There are other common multiples. This just happens to be the first time, the least common multiple there. Are there more? Sure there are. Okay, the red light blinks every 12 seconds and the blue light blinks every 9 seconds. So let's do the 9. We have 9, 18, 27, 36. All right, I'm going to stop there. Why? Because 12 and 24 and 36. So when they blink together for the very first time, our least common multiple is going to be at 36 seconds. They'll blink together, then they'll be off for a little bit, and then they'll find another match, and it'll keep on going. How do you determine when two lights blink together? Well, we do that by finding any common multiple. So any common multiple will be a time at which they blink together. All right, I just happen to stop at the least common multiple. All right, list all multiples of 10 up to 100. Awesome. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All the multiples of 15 to 100. 15, 30, 45, 60, 75, 90, and I'm out. Okay, what is the least common multiple of 10 and 15? Well, I have 30 as a multiple, 60 as a multiple, and 90. These are all common multiples, right? But the least common is going to be, winner, 30. That's the smallest one. All right, cups are sold in packages of 8, napkins in packages of 12. What's the fewest number of packages of cups and napkins that can be purchased to get the same number? Okay, so we want to find the multiples of 8 and 12 and see what's the least. So here's 8, here's 12. 8 becomes 8, 16, 24, 32, and 40. 12 is simply going to be 12, and 24, and 36, and 48, right? So, yes, 48's in common, yes, 24 is in common, but we want to find the fewest. And which one's the fewest? That's going to be the 24 is the fewest. So how many sets of plates and napkins will there be? 24. That's the winner right there. So that's going to be getting, in this case here, 1, 2, 3 packages of cups, and 1, 2 packages of napkins. All right, 1, 2, 3, 1, 2. That's where those numbers come from there. All right, the next one. Rectangle ABCD is drawn on a coordinate plane. A equals -6, 1, 2, 3, 4, 5, 6, and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere up here. B is at 1, 2, 3, 4, 5, and 9 up here. Here's A, here's B. Where could C and D be? C and D, honestly, because you have lines there, could be anywhere down this line, anywhere down this line. You could pick a point, whoosh, whoosh, and as long as it's on the same vertical line, you're going to have a rectangle. So what is the x value right here? The x value is -6, and the y value can be whatever. And over here the x value is 5, and the y value can be whatever. If this is C and that's D. So you could pick a point, 2, 2. These have to be the same though. They have to be the same in order to be on the same line, but these have to match those ones right there. And then you'll get a rectangle. All right, last question, review. School wants to raise $2,500 to support its music program. It's met 20% of the goal. How much has it raised? Well, it has done 20% of 2,500. To find out what 20% of 2,500 is, I turn 20% into a decimal, 0.20. Of means multiply, and I multiply it by 2,500. So 0.2 times 2,500 is equal to 500, so we would say $500. If it raises 175% of its goal, how much money will the music program receive? Well, 175%, same idea, of 2,500. To turn it into a decimal, I have to move it over 2 places to the left, so it's 1.75 times 2,500, and that's going to equal $4,375. All right, that's it for today. Have a great day, and we will see you next time.